As I've said before, proofs can be difficult because they're a different way of thinking, and it's a lot of different possibilities and options that you're trying to put together and choose from to make sense of whatever you're trying to prove. If you like to play chess, you can kind of think about it as a chess game. But for those of us who aren't into chess, it might be easier to think about it as a puzzle. There's all these different pieces, and you're trying to figure out how do they go together to make this picture that we want to see, which is our proof. The only thing is, sometimes you have to go looking for those puzzle pieces. They aren't just given to you. You have to figure out which are the right pieces and then put them into the right place. Right now, we're still just trying to figure out how do we connect the statements and the reasons of a proof. Right, so sometimes I give you the statement and you have to give me the reason, and sometimes I give you the reason and you have to give me the statement. Okay? We haven't gone to a full proof yet where you're providing all of that. Because right now we're still trying to get used to this idea of statements connecting to reasons. Okay? And we'll continue with that today. We'll look at another example of a proof. Before that though, we want to look at a few more properties that we're going to add to our list of properties, definitions, and theorems that are helpful for our reasons that go into our proofs. These are the properties of segment and angle congruence. Okay, these are in your notes, so if you're having trouble seeing it on the video, you've got them in your notes. You should have already read over those. But I just want to highlight these again. These are very similar to the properties of equality that we looked at in the last lesson, the reflexive, symmetric, and transitive properties of equality. Except these are the reflexive, symmetric, and transitive properties of congruence for segments and angles. And if you remember, congruence is when two figures have the same measurements, or so when two segments are equal length, or when two angles have the equal measure. We say that those are congruent to each other. And so the same reflexive, symmetric, and transitive property that we learned last time is the same here, just with congruence. So you'll see the difference with the congruent symbol there and the fact that we're talking about segments, okay, and not just values. Remember, if we're talking about congruence, we're talking about the figures being congruent. Okay? We're not talking about their measurements. That's a separate statement to say that their measurements are equal. And so here's a few more reasons that we might encounter in our proofs, or that we might need for our proofs, to show that a segment is congruent to itself, or that a segment that is congruent to another segment, and no matter how I write that, it's still the same. Okay? They're still congruent to each other, or using the transitive property as well. So these are just a few more reasons that we might need. Let's look at identifying these properties from some statements before we get to our proof. These are examples 4 through 7 in your notes in the lesson that we've been working on. And so I just wanted to highlight these of identifying when are these properties of congruence being used. What type of statements are we looking for? So if you look at number 4, it says angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. Well, that's the transitive property, because if you remember, the transitive property says that if two different things are equal to the same thing, then those two original things are equal to each other. And so this holds for congruence as well. If angle T and V are congruent to each other, and angle V and R are congruent to each other, because angle T and angle R are both congruent to angle V, then they would be congruent to each other. Okay? And so that's the transitive property. Number 5, we see that the segment JL is congruent to the segment YZ. If that's true, then the segment YZ is congruent to the segment JL. That's the symmetric property because it doesn't matter how we write it. We can flip them around and they're still going to be congruent to each other. Okay? It doesn't matter which side of the congruent symbol that they're on. Number 6, saying that a segment is congruent to itself. Okay? That's the reflexive property. Segment GH is congruent to segment GH. And lastly, again, if angle K is congruent to angle P, then angle P is congruent to angle K. Again, that's the symmetric property because it doesn't matter which side we write it on. Okay? So if those two angles are congruent to each other, then no matter how I write that, they're going to be congruent to each other. So these are just a few examples of connecting the statement, okay, these statements right here, to the property the reason that they connect to. All right, so let's look at this third example, third proof in this series of notes. In this one, it says we're given that AC, okay, given that AC is equal to AB plus AB. So in this example here, the total length of this segment AC is equal to the portion of it AB twice. Okay, so that AB plus AB, and we want to prove that AB is equal to BC, so that this portion of the angle, or this portion of the segment, is equal to this portion of the segment. And so we're going to prove that, and you can see in this example we're given the statements, and we want to provide the reasons for it. So we start with, like always, our given. So AC is equal to AB plus AB, and that was what was given to us. And the whole segment length is equal to the portion of the segment length plus that same portion of the segment length. And then our next statement says that AB plus BC is equal to AC. Okay? So let me clean this up a little bit. So what that's saying is that this total length of AC is equal to this portion of it plus that portion. So the two parts of the segment add up to the whole of the segment. Well, what allows us to say that the two parts of the segment add up to the whole segment? If you remember all the way back in Unit 1, we talked about this. This is called the segment addition postulate. The segment addition postulate says that the two parts of the segment add up to the whole segment. Okay? And so why we're using that segment addition postulate to say that second statement is because we're trying to equate AB and BC. So we want to get them in some way connected to each other. Well, the segment addition postulate allows us to connect them to each other because we can say that the two parts add up to the whole AC. Okay? So that's a big thing with proofs is like, okay, so I know this is where I'm going. I'm trying to prove that AB is equal to BC, but how can I get there? Right? How can I put these things together? And the segment addition postulate allows us to do that, to say that the two parts add up to the whole. All right, the third line says AB plus AB is equal to AB plus BC. All right, now where did that come from? What's the reason that allows us to say that? Well, if you remember, our statements build on top of each other. Okay, so I go from the first statement to the second statement to the third statement. Look at them all together. How do they relate to each other? Well, if I look here, AC is equal to AB plus AB. And AC is also equal to AB plus BC. So both of those terms, or both of those expressions, AB plus AB and AB plus BC, are equal to AC. So if they're both equal to the same thing, then I can say that they're equal to each other. AB plus BC, no, I think it's the right one. Okay. And AB plus AB. Well, how can I say that they're equal to each other? That's the transitive property of equality, right? If two expressions or terms are equal to the same thing, then they're equal to each other. Okay? So again, I was looking at the statements in succession as they build on top of each other. Okay? That's what led me to that third statement. And then now what goes from the third statement to the fourth statement? How do I change from the third statement to the fourth statement? If you notice, I had AB plus AB equals AB plus BC, and here I have AB equals BC. Well, what changed from the third line to the fourth line? Well, it dropped an AB over here, and it dropped an AB over here. Well, if you look at this equation, how are you going to get rid of those AB on both sides? You would subtract AB from both sides, right? Because you can change the same thing. If I subtract AB from here and subtract AB from here, right? If I subtract the same thing from both sides, everything is still equal. These are just, they zero out. AB minus AB is 0, AB minus AB is 0. Because remember, each of these are just representing numbers. And that leaves me with AB and BC. So AB is equal to BC. So what allowed me to do that? That's just the subtraction property of equality. Okay? So all of our reasons are based off stuff that we've learned before, okay, or stuff that we are currently learning. And so it's just figuring out, okay, how do those connect to the statements, and where did those statements come from? How did I go from line 3 to line 4, and what allows me to do that? That's what we're trying to figure out.